This video will be about mounting and installing the mechanical retracts for the Fun Scale Corsair Park Flyer model. The techniques used in this can be really used with any other model that's going to be using the 90-degree rotating retracts available from Rabid models. Let's take a look at the wing frame that we have here. So this is wing panels 1, 2, 3, and 4 joined together and are prepped for mounting the retracts. Looking at the underside, we can see that the retract mounting plates, RMP1, have both been laminated and glued in place, and the leading edges have been blended to match that of the leading edge of the wing itself. We've also, in this area here, put in this extra scrap piece of wood and then slightly beveled out and rounded this section here. This is the section where the adjustment bolt, or the bolt that moves and rotates the strut itself, will hit. Let's look at the components that we're going to need to install and mount the retracts. So here are all the main accessories needed to set up and mount the retracts. Going through them all, we have the W6 spacer. This is part of the design in the short kit. We have the specifically designed Corsair hub and tire, also available from Rabid models, and their 90-degree rotating retract unit. Some particulars about the unit for the Corsair: this strut length here is 2 7/8 inches in length. This distance is roughly 1 inch. That's only to start out with, and we'll go ahead and we'll trim that up at a later point in time. Maybe a little bit more difficult to see is the actuating wire. That is from 1/32, and from the Z-link, it's approximately 1.25 inches. And we'll show where that point is and where that bend and how it connects to the servo later on. Speaking of the servo, we have a 4.3 gram metal geared servo along with an inline speed reduction. So this slows down the servo. If your transmitter has this, you can also use that as one of the transmitter functions. This is a wheel collar that holds on the wheel to the axle, also available from Rabid models. A easy link for 1/32, and this is available from Dubro. That's DUB849 is the part number. Some small screws. These are 3/8 inch in length, and they're sheet metal screws. And then the servo mounting parts themselves for the servo, and these get glued to the wing, and we'll show that step. And the last sort of thing you'll need is some Scotch tape or some magic tape. I like to use this for mounting the servo, and I'll show more about those details. Let's get into some of the additional prep work that we need to do. So working on the wheel and hub first, the first thing that you want to do is to drill out the axles with 1/16 inch in your bit. You may even need to go slightly larger at 1.6 millimeters to make sure that they rotate smoothly. This is the wheel retaining washer or collar, and it also needs to be drilled out to 1/16 of an inch. These do come with some pilot holes to allow you for different options. However, that's what's recommended for this setup. The servo mounting parts are set up here. We'll go ahead and drop some CA on them and show you the finished product. Our servo mount is complete and lightly sanded. I've also marked a line just over a 1/8 of an inch below this piece here. We're going to put 2 small 1/16 inch holes for these mounting screws. We also have our 4.3 gram metal geared servo along with the slowing inline converter. Once we've thoroughly tested to make sure the servo's in working condition, we're going to go ahead and remove these 2 mounting tabs, and I'll show you how we're going to mount the servo a different way. So we have our screws already preset in the servo mount. They're ever so slightly going beyond the surface here. That'll help with alignment later. We've removed the pins from the servo here, and let's do a test fit. It goes in this area right here, and it will be mounted with the servo horn pin in the forward direction. So making sure that this is will fit in there, which it will, and we'll go ahead then and mount this underneath the servo, going through these ribs right here. So here is the servo mount mounted. On top here I've put a thin layer of Scotch tape. That will help allow us to later remove the servo if we should need to. And here's the underside of the mount itself. And the servo will sit on here, just like that. We'll put Scotch tape on the underside of the servo as well, and then once it's finalized in its location, we'll go ahead and put a drop of slow CA underneath it and glue the servo to this mount. Again, later if we ever need to replace the servo, we can go ahead and undo the 2 screws and cut this free. We don't want to glue it just yet, as we're going to need to do some alignment later when we actually connect the servo horn to the retract unit itself. We'll add the retract unit next. So this is the bottom of the wing center section here. You can see we've got the retract mounting plates in place. We have our spacer tool here. This was used during the construction. This goes between the 2 ribs here and will be helpful when we actually mount the retract unit. And then here's the completed retract unit. We actually showed how to do this in another video, and I'll link that to this here. What we have to first do is test fit, make sure that it fits within there, and it does. For the purposes of getting this set up, I've rotated where the landing gear wire would be 180 degrees. When we actually set this up, it's going to be pointing down, but for right now we want it up to make it easier for the setup. There are some pilot holes already in the retract unit itself. We're going to go ahead and drill those out with 1/16, and then we'll go ahead and set it back in here. We'll mount one side first by drilling holes through this. We'll use the servo screws, or those small 5/8 inch screws that we showed earlier, to mount it. Then we'll put the block back in between and gently squeeze to make sure that it's a tight fit, and we'll drill for this side here. So we have the first 2 screws mounted. We have the spacer block set in place, and next we'll go ahead and we'll drill out the holes here for the other side. Again, we want to gently sort of pull together. That's what this block helps with, to make sure that we're evenly spaced throughout the entire retract bay. One other thing to note too is that there is a left and there is a right retract unit. The unit needs to have this post on the inside of the wing, or towards the inside where the fuselage is. Let's go ahead and get these other screws in. So we have the retract unit mounted. That's what it looks like from the other side. And as we go ahead and pull it, so we have the actuator rod, which is 1/32. We've bent this 90 degree at the 1.25 mark from the Z-bend center line. We're going to go ahead and attach the servo horn along with the easy clip. Now the servo horn that we're using is the one that has the 3 holes in it, and we're going to be mounting it in the second servo horn hole. And we have now mounted the connecting rod to the horn. We'll next set the servo temporary in place. Before we turn on the transmitter and the receiver, a couple points to go over. Again, we need to make sure that we've got the servo hooked up to a slowing mechanism. This is an inline one. If you've got it on your transmitter, make sure you enable it before turning on the receiver. Again, standard speed can put a lot of stress on the airframe. It can put a lot of stress on the retract unit itself. So the speed not only makes it look more accurate in scale of the full-size aircraft, but also does less wear and tear on the model. I've turned on my transmitter and I've set the channel, and each retract unit gets its own channel. So this is going to be on channel 6 and the other one's going to be on channel 5. You want to make sure that you also have the orientation correct. So in the retracted position, as it's retracting, it's going to push the horn forward. In extension, it's going to pull it out. So I do recommend that you test before you set up your linkage here. Make sure you have it going in the right direction. I've also set up at this stage with the gear retracted that the endpoint adjustments is at 60% for both the up and the down. When we power this up, it will move it slightly, and then with the endpoint, we'll go ahead and set the endpoints of the extension and the retraction. So the way we have it set up right now, 60%. The gear is in the retracted state, and the switch is in the retracted state. We'll go ahead and we'll power up. So here you can see my transmitter. Move this slightly out of the way. And we're at 60-60. Hopefully that's not too glaring. And I'm going to hold the servo in place for right now. Notice the alignment. Now, when we glue this in place, we'll need to sort of make a mental note of how far either direction this way the servo needs to go. It needs to go right about there. So this is straight and level. And then from here I can see that it's not fully retracted, which makes sense because we're not at 100%. So we'll go ahead and we'll increase the endpoint adjustment. Okay, I'll back off just a little bit. And then now we'll try the extending. And so we've got a little bit more to go as well for that direction. Just a little bit more. So I'm at 85 extended and 102% retracted. Now that'll vary from model to model, radio system to radio system. You'll want to go until they get snug in both directions, but you can feel that the servo is not sort of overheating, which again, the double benefit of holding it in place while you're testing is you can tell when it's starting to heat up. I'm going to go ahead and I'm going to test the retraction. Okay, that looks good. So what we're going to go ahead and do next is we'll go ahead and use some slow CA to glue that servo in location. But don't forget to set your endpoint adjustments before powering off. While the servo glue is drying, let's go ahead and assemble the hub and landing gear strut. So the hub is in two pieces, and as we've discussed before, we've already sort of drilled these out. The flat side goes on the inside, and the spoked rim is on the outside. The wheel collar, wheel washer, just gets pushed on and slid down snug, and we'll show that in just a moment. So we have the wheel retaining washer pushed down, and you can see we do have excess wire available. We'll go ahead and we'll trim that off, and that will finalize the landing gear strut. So here is the installed and completed Retract unit. You can see that it fits pretty well in the wheel well here. You may need to do some sanding and some adjusting. And as with anything, it's going to take some adjustments here and there with the endpoint, as well as, you know, again, if need be, putting some graphite on there to make it move smoothly. But here it is in action. And to see it from the other side,